Good morning, children. How are you? Yes, I'm also fine. So now we are studying about the circle chapter, and many things we are discussing in the classrooms, also in the online classes. Those who are missing, tell your friends also to join the classes regularly and punctually. Also, you should be on time so that you cannot miss a single topic of discussion there. Okay, so now in this circle, what we have read the circle is made up of many points which are equidistant from a fixed point, and that fixed point is called center, and this distance is called radius. Okay, then we have read about it many terms. Okay, some terms of this, and these are tangent, secant, see, tangent, secant, chord, diameter, radius, and arc. I will explain later on. Okay, so these all terms we are knowing. Okay, if you forget, then you see what is tangent there. So tangent is the line that touches the circle as it passes by it. Okay, that means this line which is touches the circle externally is called tangent there. It touches the circle at a unique point. Okay, then what is secant and this chord, diameter, and radius? Just now I have explained. Secant and chord is that this is called here chord and secant. See, the chord of a circle is straight line segment which end points both lie on the circle, and the infinite line extension of a chord is secant line. Okay, so that means if this is the circle here, okay, so this line is secant, but if I draw the line like this only which touches the circle, so this is called our chord. Okay, so see, this is here, our chord is here, this AB is our chord, this one, and if it passes by like this, it will become a secant there. Okay, it can pass through the center, it can be away from the center, no problem there, it hardly matters. Okay, on that I have made one video, and that will really help you there, and that videos are made, this video you can watch when your teacher is not present at that time there. Okay, so this will be very helpful. So let us start this. Here is that video. So let me explain this video first to you. What is that question is saying here? Okay, in this the question is saying that, wait a minute. Okay, in this adjoining figure, OPQR is a square. A circle drawn with center O cuts the square in x and y, and we have to prove that QX is equal to QY. So what is that solution? Just see this. This is the figure that has been given. Okay, so this is the figure. What is the figure? So figure is saying that this is a square, and this circle cuts the square at x and y. So we have to prove that this distance, qx is equal to qy. Okay, so let us start this. So what is given? First of all, we'll write that only. What is given? Given is that OPQR is a square. It is given. That means all the sides of the square are equal. We know that all the sides of a square are equal. Here also, this OP is equal to PQ is equal to QR is equal to RO, and O is the center of the circle. O is the center of the circle. So we need one construction. It's not possible only without construction. Okay, so we'll do one construction, and what we will do, that construction, we will join this OX and OY. Okay, and we have to prove that QX is equal to QY. Okay, these things you have to keep in mind. Okay, how we can do this? Okay, so for that we need some construction, and we are just going to solve this only. we'll join this OY and OX. Okay, we'll join this OX and OY there. So now we have two triangles, see. Okay, we have these two triangles, so that construction also we must write. Okay, so that we can come to know, the examiner can come to know, okay, that construction has been made here. We have joined OX and OY now. Okay, now what? We are just going to prove now. Let me erase this board so that I can get a space over there. Okay, now we will go in triangle ORY and OPX. Okay, these two triangles. What is that two triangles here? In that two triangles, the radiuses are equal. And what are the radius? OR and OP are the radius that touches the circle. Angle YRO. See, one thing here you can just correct here. By mistake I have written here. One correction we can do here. Okay, now see, this OR and OP, this is not radius. Okay, this is not radius. What is that? What is it is then? See what it is. I will go a little back. Yes, see, OR and OP, these are the sides of the square. By mistake I had written there OR and OP, these are the sides of the square. You don't consider that as the radius. Radius is this. This is the radius. Just now I have seen that mistake. Sorry for that. So this is how we are just going to do this. So we will never use this as the radius over there. Okay, this is not the radius. Okay, so now OY is equal to that OR, that is equal to radius. OX and OY both are the same. That's why I've written that OY, and angle YRO is equal to XP, that is equal to 90 degree. So by RHS similarity, we can say here that triangle ORY is congruent to triangle OXP. Okay, OY and OY I have written because OX is equal to OY. Both are the same thing only. They are the radius. So we can say YR is equal to XP by CPCT. Okay, and then we have these two sides equal. Which two sides? Sides of the squares are equal also. So now we can say that these two sides PQ is equal to QR, sides of the square. Then we have just now proved that RY is equal to PX. That means from that QP, if I subtract PX, I will get QX, and from that QR, if I subtract YR, I will get QY. Understood? That is the concept of this question. We have made two triangles. We have used congruency here, and then we have used the properties of a square, and from that, using that only, we can find that these two sides QX is equal to QY also. Okay, so I hope you have understood this, and in the next class we'll learn something new, some new topics we'll discuss, some new questions we'll discuss there. Okay, till then all of you take care class. Thank you very much.